Hi everyone, welcome to lesson 11.5. It's your last lesson for your take-home unit. This lesson is about using the TI Nspire to help you calculate linear regression. Now I know you guys don't have the TI Nspires at home with you now, so on Monday and Tuesday, whether it's a B day or an A day, you're going to have time in class to finish the fluency for this lesson and work on the take-home test problems. So go ahead and take the notes for this lesson and pay attention, but on Monday and Tuesday you're going to go ahead and practice with this with the real calculators on the day. So linear regression is your aim today. Is that you can create an equation of best fit using linear regression, scatter plots, and a calculator. Okay, so that's your aim. In the last lesson, we drew lines of best fit by hand so we could model bivariate data that had been graphed on a scatter plot. In this lesson, we will see how to use our calculators to find the equation of that line of best fit. This is often referred to as linear regression. So in this lesson, we want to find the exact equation of that data, the best we can. So we're going to work on this first exercise. It's the same data set from the last lesson, the temperatures in April. So exercise 1 repeats the data. It's a survey was taken of 10 high and low temperatures in Fahrenheit in the month of April to try and establish a relationship between the day's low temperatures and high temperatures. So here is the data table of all the lows and all of the highs. Letter A says enter the data into your calculator and create a scatter plot using your graphing technology. Size the window appropriately so the data takes up the majority of the screen. So that's what I'm going to show you to do on your calculator, is to graph this on here. Okay? So the first thing you want to do is you're going to go to Scratchpad, you get this blank screen, hit Control New to get a fresh screen. And instead of hitting Add Graphs like we normally hit, you're going to hit Add Lists and Spreadsheets. So I'm going to click this. Okay, so step 1 is to add lists and spreadsheets. Okay, so that's the first thing. I'm going to get this screen here. Okay, well the first thing in my list, my X's, is my low temperatures. So in here I'm going to type in low temperatures. I'll just put in low, or I could put in low temp if I wanted to. Low temp. Okay, in the other column, I'm getting an error for me. Let's just type in low. In the other one, I guess you can't have two words, so the other one we'll put in high. Okay, so I've got a column with low and a column with high. Now I'm just going to go ahead and enter all of my data in here. The first data set is 26, then it's paired up with 49. So on my calculator, I've put in 26 and 49 for this little piece of data right here. Now I'm to the next piece of data, 28 and 50. So I'm going to put in 28 and I'm going to put in 50. And I'm going to keep doing this until I get all of the data in. So I like to check it off to make sure I've done it. The next one is 30, 57. Then I have 32, 54. Then I have 34 and then 60. And if you hit your arrow down, you'll get more options to put in the information. 35, 58. So, oops, I didn't hit tab. 35, 58. So I've done this one, this one, this one, this one, and this one. So I'm up to 37 now. So 37, 64. 38, 66. Okay. And then two more. I've got 4163 and I've got 4572. So I've plugged in all my numbers into the lists and spreadsheet. Okay? That's my first step. Okay, so I'll put that in here, is that you plug in the data. Your third step now, and I'm going to write this here, you're going to hit Menu. Then you're going to hit Statistics, and then Stat Calculations, and then Linear Regression. So on my calculator now I'm going to go to Menu, I'm going to go to Statistics, Stat Calculations, and see where it says Linear Regression MX plus B. That should be a very familiar formula. You're going to click that. you'll get this menu here, and this menu here is wanting you to define what your x and your y's are. So all you have to do here is type in what you had originally put in your list. So if I look at my table, I know that my x's right here are my lows. So I'm going to click down here, and it already has high and low in here for me because I already typed it in, so I'm going to hit low. And my y was my highs, so for y I'm going to define it as high. Okay. The next options, you don't need to change anything. Okay. See where it says save reg equation to F1? This tells you where you're going to find the graph. So after I put in low and high and define my x and y, I'm going to hit OK. It's going to give me this table, which is really, it's going to give me some information here, which is important information. If I scroll up, it's going to give me the equation. Here's mx plus b. It tells me what m is. So there's m, 1.1. B is 19.07. And then this piece right here, this r that I've highlighted right here, that's important too. But letter A just wants us to create a scatter plot on the graphing calculator. So how can I get out of this menu and actually see my scatter plot that I've made? So we need to open a graph page. So I'm going to click on my calculator, Control Document, and I'm going to hit Add Graphs, like I normally would. Okay, now notice how it says starts with f of 2. Well, if I scroll up, push this button to scroll up, my equation shows up at F1, this really crazy long thing. And if I hit enter, it's going to graph it. Now my window's not big enough, so I have to make a bigger window. So I can go to Menu, Window, I can zoom out here, and I can start to see there's my graph. Now that's a line, but how do I turn this into the scatter plot? Because I want to get all the scatter plot of that data. So how do I do that? So if I go to Menu and I hit Graph Entry Edit, I get this option called a scatter plot. If I hit scatter plot, it's going to ask me to define x and y. Well, this is very similar to how we defined x and y earlier with our table. Well, I know that x was low temperatures, and I know that y, and I know that my y was high temperatures. Hold on a second, sorry, let's try this again. So x was low. Oh, it's giving me an error and I don't know why. Let me try hitting the variable button here. Yeah, here we go, here they are. So let's hit low here for x, and for y I'll hit variable and I'll hit high. And when I hit enter, I should see my scatter plot. Okay, now you're probably thinking, hey, I can't see any of my scatter plots. Nothing happened when I hit enter. Well, if you go to Menu and hit Window Zoom, and you hit Zoom to Data, it'll suddenly show you all of your little plots in the window that you've made. Okay? And you can also, if you want to view your, let's see, the grid. Sometimes showing the grid is really nice, in that line grid. There you can see exactly where your dots line up. Okay? So this is how you can set up the scatter plot onto your calculator. And the great thing about me showing this in a video is if you've forgotten a step, you can skip back, rewind, hear what I said again, which is what's so awesome about recording these videos, that, you know, if you missed a step, go back, rewind. Okay? So that was letter A, just getting the scatter plot onto my calculator. So what does letter B want me to do? Now letter B says use your calculator to find the equation. So we have the graph, we have the plot. What is my equation? So I'm going to go back to my calculator, and I'm going to click on that first document, 1.1 here. And I have my equation right, I have my equation, I have my m, and I have my b. So I know that my equation is going to be in the form of y equals mx plus b. And my equation, m is, let's see, if I click on my calculator over here, m is 1.16. So I have 1.16x. And my b value is 19.07 plus 19.07. Another place you can see that as well too is if you click on the other table here and you hit tab. If you have to hide this menu and go back to your F1 keys, you can, but it's a lot harder to get to that information. So the best place to find it is in that original table. And for some reason my computer is doing something very weird. I'm not sure what that is. Oh, it's mad because there we go. It's mad because I accidentally deleted those. Let me fix that real quick. There we go. Back to normal here. Okay. Alright. Okay, so there's my equation. Now, on the last lesson, I did make a mistake, which I'd like to point out here. So I've copy and pasted the previous lesson's slope calculation, but my mistake is pretty clear here. If you notice, what did I say here? I put 36 minus 42, and I put that that's 8. That's not actually accurate. So the actual equation that we had here was 70 minus 60 over, it should be 42 minus 36, to give you 10 over 6. The number doesn't change a lot. 10 divided by 6, 10 divided by 6 is 5 over 3. Oh. Hold on, sorry guys, my pen is kind of acting up a little bit. Let me go back a little bit. Okay, so this becomes 10 over 6, which gives me 5 over 3. And when I simplify 5 over 3, I end up getting 1.25. So it's not a huge difference, this 1.25. But notice that the slope I calculated, 1.25, it's pretty close to the 1.16. It's not exact, but using just my scatter plot and picking 2 random points, I found my slope very similar to what the calculator found. Okay. Letter C says, explain what the y-intercept of this model represents in terms of high and low temperatures that are being modeled in this problem. So if I look at the y-intercept, what is my y-intercept? It's 19.07. What does that mean in terms of the real situation of this problem? Well, let's think about that for a second. The y-intercept is always when x equals 0. That's always what the y-intercept is. But if we look at the table, come back up to the table, do you see x0 at all in any of these numbers? No, none of the x's are 0. So this number right here, this 19.07, is a prediction. It's saying if the temperature was 0, then the high temperature, if the low temperature was 0, then the high temperature would be what? As a prediction, would be around 19 degrees. That's what this is saying, which is an estimate, right? Which is what's really nice about statistics. You get a bunch of data and then you make estimates about what you don't know. So we don't ever have a day in April where the temperature was 0, but if the low temperature was 0. But if we did, it'd be a really good guess that the high temperature that day would be around 19 degrees. Okay? And then the same thing here, we're making another estimate about the slope. So if the slope of this model, how could we interpret the slope of this model in terms of the high and low temperatures? So what are we really saying? The slope is about the same way we were saying that the y-intercept was about. And really all the slope is saying, the slope is just saying that, look, here's the rate at which the high temperatures change compared to the low temperatures. So the slope is the rate at which, I got a new pen finally, but it's taking me a little bit of time to get used to. Okay, so it's the rate at which the output, which is your high temperature, is changing compared to the low temperature. Remember, slope is always rate. Slope is just another word for rate. So it's the rate at which the output is changing compared to the low temperature. Okay? And I'm sorry my handwriting is so bad. This new pen's taking me a little bit of time to adjust to it. Okay? So we can also say this, in other words, we can say for every 1 degree increase in low temperature, the high temperature predicts a 1.16 change. Right? Because that's what we get, the 1.16. That's our slope. Okay? Wow, this pen. Sorry my handwriting, guys. It's 1.16 change. Okay. Okay. So let's try again with another set of data using the calculator, because I know this is a lot of information. You're using a lot of decimals. You're thinking about slope and y-intercept, but keep in mind, you're just thinking about linear relationships. Slope, y-intercept, plugging in some data, making an estimate. This is all about estimating with data. So let's take a look at the second example, exercise 2. So exercise 2 says generally the fuel efficiency of a car changes with the weight of a car, meaning that the heavier your car is, the worse fuel mileage it gets. And fuel mileage, or fuel efficiency, is like how far can you drive without having to put more gas in your tank. Okay, this is not something that you guys deal with a lot because none of you drive and a lot of your parents don't drive, but fuel efficiency is something that people look for when they go to buy a car. The better fuel efficiency your car is, the less you'll have to buy gas. So it's a really good thing. Okay, so they took a survey of some cars with their weights and gas mileages shown below. So this is all this data here, and it's all kind of mixed up. So letter A says, find the equation for the line of best fit using your calculator. Round both coefficients to the nearest tenth. List what the x and y represent in this problem. Okay, so first of all, we're going to think about what should be x and y. Okay, so in a table, let's think about what our input and output is. In this table, we're putting in weight of the car and we're getting out a mileage. If a car is this weight, it has this much mileage. If a car is this much weight, it has that much mileage. So the weight is your x and your mileage is your y. So that's the first thing we have to think about. So I'll do that here. So x is your weight and y is the mileage. How far can you go before putting gas in your car? Okay. So now let's get a new document here. So let's go to my calculator, hit Control-N, and clear all of this. Do you want to save changes? No. I don't want to save any changes, and I want to add lists and spreadsheets, right? In column A, I want weight, and in column B, I want mileage. So I'm putting in mileage. Now I'm going to go ahead and put the data in. So I have 3.7 and 38. I'm going to check that off to show I put it in, because it would really be unfortunate if you skip a data point. You'll get your answer if you miss a data point, you'll get your answer completely wrong. So I'm putting one in and I'm checking it off when I'm done. Next one is, oops, I accidentally put 3 on there. The next one is 3.2 and 48. So that's this one right here. Next one, 5.1 and 24. So if the car weighs 5.1 thousands of pounds, it's going to have 24 miles before I put gas in it. So there's that one. The next one, I'm going to scroll down a bit here in my table. So I have 6.8 and 18. Next one is 4.9 and 30. Okay, I've got 2 more left. 4.8. Oops, I did it again with that thing. 4.8 and 28. It is time consuming. This should take you some time. It's taking me time on here, right? To go back and forth from my table to my calculator, making sure I'm putting in every data point. 5.5 and 21 is my last one. Now, notice how I've stopped at 8 here. There's the 8. So I'm going to count and make sure I have 8 sets. So 1, 2, 3, 4, 5, 6, 7, 8. Good. So I've put in all of my data. Okay. Now I have to find the line of best fit. So what do I do to find my line of best fit? So I don't hit enter here. I go to Menu, Statistics, Stat Calculations, and linear regression, mx plus b. Okay, I've got to define my x and y. Remember I said that x was going to be my weight and y is my mileage. It's nice to start these in there for you. You hit OK, and it's going to tell you what your equation is, your line of best fit. So here in my data, I have m, which is right here, and I have b, and I have my correlation coefficient here. So this m is negative 8.09. It wants me to round to the nearest tenth. So when I write my equation, I get y equals, m is negative 8.09, But if I want to round that up, I'm going to round it up to negative 8.1. So it's going to be negative 8.1 x, because that's my m. And then on my other part, I need b, which is right here. That's my y-intercept, plus 68.09. That's going to also round up to 68.1. So I'm going to have plus 68.1 as my line of best fit equation. Okay, so this is my m, and this is my b, which I found over here where it says m and b in my table, and I just rounded it up to the nearest tenth. Okay, now there's something else we have to talk about, and we've got to talk about correlation. So this letter B now says create a graph. So create a graph of the scatter plot for this data. Because this didn't have me graph it first. Well, I'm going to go to my calculator. I'm going to hit Control Document to get a new document, hit Add Graphs. Just like before, it's going to have my equation in here. It didn't round it, but the calculator doesn't know to round. So I'm going to hit Enter, and I can see the line over there, so I know that I've got to zoom out a little bit because I can't see the whole thing. So I'm going to zoom out until I can see it. And now I want the scatter plot. So in order to get that scatter plot, like I said before, you go to Menu, Graph Entry Edit, and hit Scatter Plot. I need to define my variables again. So to do that, I hit Variable. My X variable was weight. Oh, I put it in the wrong place. Sorry about that. My X variable was weight. So I'm going to put weight, and my Y variable was mileage. So I put them both in here and hit Enter. Like last time, those scatter plots didn't show up, so I'm going to hit Menu, Windows Zoom, and I'm going to zoom to the data. And there I can see my scatter plots lining up. And I can see that this graph, is this an increasing or decreasing graph? This is a decreasing graph. So because this graph is decreasing, that means that I have a negative correlation, right? Which is basically saying that as my weight gets bigger, my mileage decreases. So as my weight increases, remember that's what negative correlation means, as my weight increases, my mileage decreases. Which is why a lot of people buy Hondas and Toyotas, little cars, because they weigh a lot less, so they get a lot more gas mileage. You see people driving with big trucks and Hummers and SUVs, and they pay a lot more in gas because their cars are heavier. That's what this scatter plot is saying. Okay. So letter C says, which parameter of the linear model predicts whether the correlation is positive or negative? Use this model to help explain your answer. This is a really easy question. This is saying what part. Parameter is a fancy word for saying which part. Which part of the linear model? Well, there's only a few parts of the linear model. You have your slope, you have your y-intercept, and you have your x and your y. Which of these three explains whether it's increasing or decreasing? The winner is slope. If your slope is positive, it's going to be a positive correlation. If your slope is negative, it's going to be a negative correlation. Well, let's look at our slope. What's our slope? It's negative, so we have a negative correlation. Okay? So that's a really easy way to see whether something is positive or negatively correlated. All right? Letter D. If a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency round to the nearest integer? Okay, well, first I'm going to rewrite my equation. So y equals negative 8.1x plus 68 oops. Oh, see, I'm getting used to this new pen, I tell you what. Plus 68.1. So what is this 4,300 pounds about? Well, if I go back to my table, notice that weight is in thousands of pounds. So I have to turn this 4,300 into just 4.3. Okay? So I'm going to have 4.3, and then I'm going to plug this in for x. Because x is weight. So my new equation will be y equals negative 8.1, but instead of x, I'm going to put 4.3 plus 68.1. And if you had your calculators, you would need to do this on a calculator because this is kind of difficult math to do in your head. You end up getting 33.27. They want you to round to the nearest integer, so I'm going to leave this at 33. Okay, and the correct units would be miles per gallon, because that's how you describe mileage. So we can use our model to predict what kind of gas mileage a car would get. Okay, and then this is the same type of question, letter E. If we wanted to purchase a car that got 40 miles to the gallon, what would the weight of the car should we purchase? This one just wants you to now plug in 40 for Y. So here I have 40 miles to the gallon. I have my equation, negative 8.1x plus 68.1, but now I'm going to plug this in for Y. So I have 40 equals negative 8.1x plus 68.1. I have to solve this equation. So I'm going to subtract 68.1 on both sides. I end up getting, let me give myself some more space here. I end up getting negative 28.1 equals negative 8.1x. Divide both sides by negative 8.1. And I get on my calculator that x equals 3,000, oh sorry, not 3,000. I'm reading my calculator wrong. 3.4, oh, I'm still in eraser mode. Sorry, 3.4691. This problem wants me to give it to the nearest 100 pounds, so we're going to say that this is the same thing as saying 3.5, but if we convert that into thousands of pounds, we get 3,500 pounds, right? Because we want to make that into thousands. Okay, so a lot going on in this lesson, but really practice is what's going to make this happen for you. I've seen linear regression on every Common Core Regents that they've given in New York, so this is something that you can practice a lot and be really good at it. You know, it's really just plugging in the data in the calculator and being able to read the information you get. Okay, so on Monday or Tuesday, A or B day with Ms. Vasquez or with me, we're going to give you guys time to finish up this lesson and finish up the take-home test. I know this lesson took a long time, and I apologize for that, but I want to make sure that you guys are feeling good about this. So please email me if you have any questions, and I'll see you guys after spring break.